Hello and welcome to probably one of the most interesting lessons on the unit of vectors, the dot product. Remember that so far we've looked at geometric vectors, which are practically vectors on a plane, and then we've looked at algebraic vectors, which are vectors located on the Cartesian plane. We have learned how to add two or more vectors by using the triangle and parallelogram law. And similarly, we've learned how to subtract two or more vectors using the same rules of triangle and parallelogram law. And we've also learned how to multiply a vector by a scalar k. In this lesson, we will learn how to multiply two vectors, and there are different ways of multiplying two vectors. Our focus for today will be the dot product, which is a form of multiplication. So two vectors, u and v, can be multiplied by what we call the dot product, and we read it the exact same way as you see it, so u dot v. And the answer will be the magnitude of u times magnitude of v times cos theta. As you can see here, we have the product of magnitude, which is a number with another number, and cos theta is a number as well. So the product of three numbers will give a number or a scalar. And this is the reason why very often we refer to a dot product as the scalar product. So to find the dot product of two vectors when we know their magnitudes and the angle made between them, we simply use the formula given, and we say that, for example, if vector u here equals 4 units and vector v is 5 units, and together they make an angle of, this looks like a 50-degree angle. Let's make it interesting, 52-degree between the two vectors. Then we will say that the dot product u dot v equals magnitude of u, which is 4, times magnitude of v, which is 5, times the cosine of angle 52. And if you multiply these three numbers together, 20 times cosine of 52, we get 12.3. So we'll say that the dot product u dot v is 12.3. Now, dot product is very useful to find the angles between two vectors. And we do that just by simply using the same formula here. And what we do practically is solve this formula for cosine of theta. And we say that cos theta is u dot v divided by the magnitude of u times magnitude of v. Now, as you can see in here, the dot product of these two vectors ended up being 12.3, or positive number. Now, as you can imagine, cosine of theta, if the angle is acute, will be a positive number. So that will make the dot product a positive number. Now, if the angle made between two vectors is 90 degrees, the cosine theta will be 0. And that will make the dot product equal to 0, because then we'll have u times v times 0, which equals 0. Now, if angle theta between two vectors is bigger than 90 and less than 180, obviously, then the cosine ratio will be negative. So that will give a negative dot product. So as you can see, a dot product can be a positive equal to 0 or a negative number. Now, we have an app in here that we are going to actually take a look at, the dot product live, and see how that works. Give me a few seconds. And here we go. We can access it more easily from here. Open it, and here we are. So what we have in here is two vectors, u and v, and the angle between them at this moment is 69.6 degrees. So we are finding u dot v, and if you look on the left side of the screen, see that this appears right here on where I just highlighted it. And the value u dot v is 7.5. Now, if we change the value of the vector, now you can tell that the value of dot product will change. That's because the magnitude is becoming bigger or smaller. So when the smaller the magnitude, the smaller the dot product. Same applies if we change the magnitude of vector v. So if we change the angle on the other hand, so I'm going to make the angle equal to exactly 90 degrees. Oops. That's kind of tricky. So you can tell that the dot product will become 0. All right. I think that it goes by 0.2, that's why. So the dot product will be practically equal to 0 at 90 degrees. So if the angle between two vectors is bigger than 90 degrees, notice how the dot product is negative 8.9 in this case. So it's a negative number. So we're going to say that just like we find the angle between two vectors by using the dot product, or just like we find the magnitude of the dot product, and we're going to say that we're going to derive some very important conclusions. We're going to say that if two vectors are perpendicular, dot product is 0. If a vector is dot producting itself, it means that the dot product will be the magnitude squared, and that is because the angle a vector makes with itself is 0, and cosine of 0 equals 1. So that would be the magnitude of u times 1 squared, obviously, times 1, and then we have the magnitude of u squared only. Now, the dot product enjoys associative property with a scalar, which means that a scalar multiplied by the dot product will give ku times v. So you can multiply by the scalar either k or v, okay? And the answer will be the same. The distributive property means that if you are dot producting a vector with the sum of two vectors, that would be the dot product of vector u with v plus the dot product of vector u with w. And also the commutative property, so u dot v and v dot u give the same value. And we can understand that easily seeing that just by looking at the formula. So in multiplication, the order doesn't matter. Now remember that the unit vectors on 3D, which are I for the x, j for the y, and k for the z axis, will be related to each other perpendicularly. So if you multiply two unit vectors, for example, I and j, or I and k, or k and j, then the dot product will be 0. That's because they're perpendicular, and when vectors are perpendicular, then the cosine of 90 is 0, and that's what makes the dot product 0. On the other hand, the dot product of a unit vector with itself will be equal to 1 because a vector will make an angle of 0 with itself, which makes the cosine equal to 1, and the dot product will be 1 times the cosine of 0, which is 1, so the answer will be 1. So now let's take a look and see how to find the dot product of two vectors if the vectors are given or are on the Cartesian plane, and it's kind of interesting, easy, and a lot of fun to do. So here we have two algebraic vectors, and we know that in order to work with algebraic vectors, we prefer to bring them in the position form. So we find the respective position vectors, in other words, and that's very easy. We just slide the tail over to the origin, and I'll do the same thing with vector v. Okay, and let me drag this with the tail at the origin. So I'm going to start off by explaining how we do this by using numerical values, because that can be easier to see. And I really want to bring this u in here. All right, I did it. Okay, there we go. So we're going to say that if vector v has the coordinates, let's take a look at vector v, coordinates 5 and 12. And vector u has the coordinates 3 and 4. then we'll say that the dot product u dot v equals, I'm going to start with vector u, 3, 4, and vector v, 5 and 12. So to multiply two vectors by the dot product, I want you to pause for a second and think about it. In what ways can you multiply the two pairs, right? So the two sets of coordinates. So what would be unimaginably possible way of multiplying? So there is no right or wrong answer. So as you probably might have guessed already, to multiply, we are going to follow this order. So we multiply the x's together, which means we multiply 3 by 5, and then we add to it the product of the y coordinates, which are 4 and 12. So 3 times 5 is 15, and 4 times 12 is 48, and the answer is 15 plus 48, or 63. So we're going to say that u dot v equals 63. So in general, we're going to say that the dot product of two vectors u and v, where u is x1, y1, and v is x2, y2. So these are the coordinates of the respective position vectors. The dot product u dot v equals, I'm going to start with x1, y1 dot x2, y2. And as you saw, we are multiplying x1 with x2 and adding to it y1 times y2. So this is how you would write the general formula when we dot product two vectors. Now this is in 2D, but if you are in 3D, as you might imagine, in 3D we have to add the third coordinate, so the product of the third coordinate, or the z. Now you are probably wondering, so wait a second, we found the dot product of two vectors by simply using the coordinates. So you multiply the coordinates. Whereas in here, in the previous example, we found the dot product by using their magnitudes. So how are these two related to each other, or are they related to each other at all? So in order to convince ourselves that yes, this formula works, you can dot product each side, and that should give you the same answer, because obviously we use a different method of dot product when we use coordinates and when we use magnitudes. Then what we're going to do is, since we already found the dot product by using the coordinates, we're going to try to find the dot product by using the magnitudes. And as a reference, we're going to use the exact same vectors here. So what I'm going to do, just so that we organize the information a little better, I'm going to take this diagram on the next page, and our task now will be to find the dot product by using the magnitudes of this vector. So let's do this. So I have decided to find the dot product u dot v by using the magnitude of u, the magnitude of v, and the cosine of the angle between the two vectors. And there is the angle made between the two vectors, and I'll call it the angle theta. Now, in order to use this side of the formula to find the dot product, I'm going to need to know what the magnitude of u is. So I'm thinking, if we know the coordinates of vector u, can I find the magnitude of it? So we're going to say that for vector u, the coordinates are 3 and 4. That will make the magnitude of u equal to the square root of 3 squared plus 4 squared. In other words, 16 plus 9, that's a 25, square rooted, and we got the magnitude of u equal to 5. In a similar way, we'll find the magnitude of vector v. The magnitude of v will, considering that vector v has the coordinates 5 and 12, will be the square root of 5 squared plus 12 squared. That will be 25 plus 144 or 169. And that gives us the magnitude of v equal to 13 units. So the next thing we want to find is the angle that the two vectors make with each other. So we will have to figure out what this angle is by using the diagram here. Now, if you think about it, the angle between these two vectors, which is the angle made when vectors are placed tail to tail, would be equal to the angle that vector u makes with the x-axis, that's the bigger angle, and the angle that vector v, the green vector makes with the x-axis, and the angle, take away the angle that vector u makes with the x-axis. So I'm going to call the angle that vector v makes with x-axis alpha. So let alpha be the angle v makes with the positive x-axis. And we're going to let beta be the angle that vector u makes with a positive x-axis. Okay, so I'm going to put the information up here so it connects with the diagram, and here we go. So let's draw the angles as well. So this would be the angle beta and this would be the angle alpha right here. So we know that angle theta, which is the angle between the two vectors, would be equal to angle alpha minus angle beta. So we can easily find both alpha and beta because we know the coordinates of each vector actually, so the head of each vector. So for alpha, we're going to say that equals inverse 10 y over x. That's a formula that we have learned. So 12 over 5. Now, even if you forget the formula, remember that here you have a right angle triangle. And you know the components, they're 5 and 12. And the angle is opposite the side 12. And then you use the 10 ratio there. So I'm going to use a calculator to find this angle. So second 10, 12 over 5, which equals 67.3 degrees. So alpha is 67.3 degrees. In a similar way, I'll find beta, which will be inverse 10. And I'm going to use the components of vector u, which are 4 and 3. So y over x, which is 4 over 3. So 4 over 3. So that will give angle beta equal to second 10, 4 over 3. So that's 53 degrees. 53.1 to be more precise. So we're going to say that angle theta then must be 67.3 minus 53.1. So 67.3 minus 53.1, which will be about 14.2 degrees. So theta is 14.2 degrees. So now we're going to take a look at our formula and check and see. We got everything. So we got u, which is 5. We got v, which is 13. We got angle theta, 14.2. So let's put them together into the formula to see what we get. So we're going to say that u dot v equals magnitude of u, which is 5, multiplied by magnitude of v, 13, and then multiplied by the cosine of the angle, 14.2 degrees. So 5 times 13 times cosine of 14.2, I got about 63 in here. So let's take a look at what we got when we found the dot product by using the coordinates. As you can see, we got the exact same answer, so 63 units. So remember that we can find the dot product by using the coordinates. So multiply the x's together, the y's together, and then adding them. Or we can find them by finding the magnitude of each vector and or using the magnitude of each vector and the cosine of the